Very good. Let's start. So a couple of words before I start the demo itself. When you study, let's say, electrical engineering, right? How this is happening? First, the teacher gives you basic laws of physics, right? After that, electrical laws, like for example, Ohm's law, right? Then you familiarize yourself with inventions that happened in the past, like for example, like what Tesla did, how microwaves are working, and step by step, you um, evaluate what's already been there before before you, right? And only once you master existing things, you are reusing what's been done before you in order to like contribute something else, in order to improve something, right? And that works not only in engineering, not only in electrical engineering, but in programming as well. So when we want to deploy something, we do not reinvent, for example, assembly code, right? Or we don't, if we want to calculate some, let's say, mathematical expression, like we did in our previous task, in our previous session, we do not write the code itself that makes this calculation. We just call the function that was already written for us, and that's doing this job. And in effect, programming, technology, including DevOps, including cloud engineering and automation, is about taking what's already out there and adding additional abstraction that contributes towards solving your own business case. And then you can contribute it back so other people can reuse it. That's how it's working. And getting back to our original example, you don't have to reinvent, for example, Newton's law, right? Or you don't have to reinvent the basic physics, rediscover the basic physics of how atom and electron works, right? You just read in the book and use what's already for you. You don't have to reinvent a wheel. It's already been there for you. You need to spend your time effectively and efficiently by taking advantage of what's there already for you. Same situation, getting back to our use case, same situation happens when we write Terraform code. So there is a thing called Terraform registry, and let me show it to you. Where you can use already defined, already created, validated, and tested modules for your own infrastructure, for your own task. For example, let's say you want to create a VPC. Actually, you don't have to create it from zero and define each resource separately, like define a route table, define network subnets, and calculate CIDRs and all these things that we did. You might ask, why then we've been wasting our time on this? We've been doing this mostly for the educational purposes, to get you familiarized with how it works, first of all. Because if you want to be a good engineer, even if you have a tool, you need to understand what's inside, and being able to open, for example, the source code of this tool and find out or clarify something, right? But overall, almost all infrastructure is written using, I would say, like in 90% cases, using these publicly available open source modules that already defined. And it will look like this, much more simpler. You just pass the required variables, parameters, similar to how we did with our own modules, but in this case, we don't even have to write the module source code itself. And if you want to find out more information about this, about each in particular model, you can go to, for example, inputs property and see which property, like complete index of all properties that you might want to pass there. And same thing for outputs. And also, of course, you can click this GitHub link and it will redirect you to the source code of the module itself. And getting back to the question why we've been reading modules from scratch from the very beginning, because now you open this and it will make complete sense and you will be able to read these internals of this module and understand what's happening inside. And for example, if there is an error or if there is an extra use case that you want to implement, you could either, for example, modify this already existing module for your needs, or even modify this and contribute it back to the community and help to improve the technology. But for now, for today, we will rewrite everything, all infrastructure that we had so far, like almost all infrastructure that we had, using open source Terraform modules. Okay, and let's create a branch. And basically, we will start. Any questions so far? Okay, very cool. What I'll do is I'll delete this and do my own new module. Actually, not my own. Sorry for that. And how do we use open source modules? We simply, same way we pointed it to a local folder, we can point it directly to, to the module registry. It will pull it for us directly from here, and we will use it. It's very similar to this example. Yeah, here's how it will work. Let's put module source and module version. And we can run Terraform in it. And you see it is pulling this module from Terraform registry. And when you want to go and check what source code in this module exists or what variables it can go, once you pull the module from here, right, you don't even have to go to this web page. What you can do is just go to .terraform modules VPC, and here is the full code of your module cloned into the .terraform folder, same as you demonstrated you on GitHub. So that's another reason, by the way, why we need to remove .terraform from Git and always have it in git ignore. Okay, so yeah, then let's move forward. I'll pass the following parameters for it. So it is slightly different. It wants availability zones to be passed at a variable. It does not to find out which availability zone available by default. And what we'll do is do like similar data source and pass the value of this data source into the as-is property. Okay, cool. So we have already run Terraform init. Now it is time to run Terraform apply. Not quite. Let's think about this together. Why you think there is an error? What's the reason for this error now?
It's in the output file, so I think we're not supposed to reference the output in this case in the same way we were referencing it when we created our own module.
Yes, if I understood your description right, you are correct. So in our module we have one type of outputs, but in the publicly available module, yeah, we can again go here in the code and check it outputs.tf. It has VPC ID, and in our case, it's no. Let's find CIDR. Yeah, in our case, we had VPC CIDR. In case of this public module, it is VPC CIDR block. Simply name of variables, name of properties are different. So let's go to outputs. So it will be then, let's put it like here. Instead of VPC CIDR, there will be VPC CIDR block. Instead of private subnet ID, let's find it. It's just private subnets. And this means VPC ID, in our case, it's a match. Very good. Let's try again. Hopefully it will work now. No. Hold on a second. It says private subnets. Okay, very cool. And while it is applying, we can move forward and configure the rest of our infrastructure to use open source modules as well. Where can we move forward? Okay, let's start with ASG. So we'll put this one. The idea is similar. I have it in my notes, but in your case, you could have go and search for Terraform AWS ASG module. Terraform AWS ASG. Like this. Check module inputs, check its source code, make sure you understand how it's working, make sure you know how to use it, and then move forward with the implementation. And in this case, it has quite a lot of parameters, so I'll just copy paste them, and after that we'll go through them together, if you don't mind. So what it tells to us? That it has mean size, max size, and desired size. That it has type of health check EC2. There is also health check ELB. That's purely auto-scaling term. That means like if health check is EC2, when status checks of EC2 instances are failing, the instance will be replaced. And if the health check is LB, it will remove the instance if ELB stops responding. VPC zone identifier, our private subnets, target group, our load balancer, some details about launch templates, our AMI, instance type, key name. We don't need a key name actually. Our user data script, and we'll need to put it back into here. Simply because we don't have this inside module, we are passing it as an external thing. Details about IAM role and what policy to attach to this role, right? And again, if you want to better understand, that's just input variables, right? This doesn't mean anything, and you can declare anything. You can contribute to GitHub, create a pull request, and if it's accepted, extra variable will be added or removed, and this always changing. The rule is simple. You should always go and check either documentation about each particular module or the source code, either on GitHub or in your Terraform folder after you run Terraform init. Okay, not sure if it will work. Perhaps there will be some additional dependencies, but let's at least try. Okay, it expects our security group to be a module as well. So we can do this. And also our Amazon Linux data source, it also wants it. We removed too much things. So let's restore our Amazon Linux data source to fix the first issue. And let's create private security group also using a module. So in case of security group, it's, I would say, like questionable. I don't have any like strong opinion about whether to use security group as a resource or security group as a module. Why? Because it looks like it's not simplifying too much, and we still have like similar number of code. Doesn't matter if we calling the module itself or calling the security group directly as a resource. But sometimes there are tricky configuration that make it really complicated, and in this case, module starts to make sense. But that's basically what we do, right? That's private one. Okay, and also, where is our auto scaling? 1 second. Oh, sorry, auto scaling security group. No, that's different thing. Let's run Terraform plan one more time. And to fix the rest of errors, we need to add load balancer dependency instead of this module. Again, as usual, we will use the publicly available one. So that will be like this. And we are passing all the required variables, again, as usual. In what VPC it should run, type of load balancer application, network load balancer, whether it's external or internal. We are putting it in a public subnet. We are giving it a security group that we will also define using a module. We open on this security group for hot reto everyone, right? What else we can do? Target group with our health check defined, the listener, and the certificate that is also declared as a module. And yeah, let's move forward and create our DNS record and a certificate assigned to this record. And there is a question, yes. No, that's Geoffrey disconnected. Okay, let's then move forward. Yeah, Mohammed.
Yes, I sent the question on the chat. So my question is, why Terraform public modules is not working with our local modules?
There is not because we have different namings. We need to match namings.
Okay.
So, for example, public module might expect some input in slightly different format. For example, when we expose, let's say we expose single subnet ID as a string, it perhaps might expect to get it as a list of strings, right? So it will definitely work. You can have one module as your own, and another module is a public module. Yeah, that's a use case, but you need to make sure that the data types are matching.
Okay. Thank you.
And yeah, and just to save time, because we have a lot to do, I'm just doing straight like everything with our modules, and it's easier. Like, what's the point for us to make it work with local module if next local module that is a dependency for the module that I'm showing now will also be replaced with open source module as well, right? So that's why we are putting the everything like straight there. Let's run again. Every time we add a new module, we need to run Terraform init. Was already declared in TF resource name. Okay, yeah. Let's then remove our DNS and ACM completely, since we already have the module declared as a local module. And the rest is the security group ID. Let's check for RDS as well. So first, we'll create an RDS security group that allows basically MySQL traffic from our private security group, which is used by autoscaling, and deploy an RDS. So storage, type of engine, type of storage, type of engine. We can pass anything, and automatically it will deploy either Oracle or whatever we would like. Which port it will use, the DB name and everything else. We have our secret still in our data source, so it will continue working as it was before. Don't forget to put this property, otherwise it will be really difficult to destroy and really long to destroy this security group, the one that we created here. Subnet IDs are private subnets. Again, Terraform init. And Terraform plan. And some outputs. Local RDS password. Let's see what we got. We don't have it declared as a local. 1 second, let me fix this. So probably instead of this, we didn't use this construction here. We didn't put it as locals. Instead, let's pass it directly. Let's refer secret manager directly. Module RDS, and also fix our remaining output. RDS address. Okay. So I don't remember what right properties is supposed to be here. What's the right property name for the public module? It's named differently from what I have declared. And it's a perfect way to demonstrate how we can use it. Again, we go to .terraform folder, go to modules, find our RDS module, go to outputs, outputs. And let's search for something that looks like what we need. Probably this one, database instance endpoint. Let's run again. And our outputs don't match again. Let's have a look what we need. There is no attribute private subnet ID. Yeah, this time I just copy pasted not correctly. So instead of private subnet ID, it should be public subnet, private subnet. And also public. And as usual, please excuse me, I made a misprint. Cool. Oh, let's try this out, and hopefully it will work and we don't have to debug. Or even when we need to debug, we're learning new things together. So that's not a big deal. But anyways, it will take roughly like 10 to 15 minutes to deploy RDS. Yeah, RDS takes long. We can, and I will appreciate if we don't like awkwardly, don't just sit awkwardly silent, but have some open discussion about, first of all, let's start if any of you guys have questions regarding what I have just demonstrated. Maybe I've demonstrated it too fast or something else. And otherwise, we can discuss any previous topics, any clarifications that you might have. Claudia, you raised your hand. Move forward, please.
Yes, I have a question. So, like now we have used like these modules that I suppose published by AWS themselves, like they are defined by them. Is there a way like for us to create our own modules and like maybe publish them to like a private repository in the registry and like use them later, like just like Docker Hub principle? Does it apply
Yes.
here or not?
Yes, it is totally possible. And in fact, we've been doing this previously. We've been creating our own private module that sits in the same repository that the code itself. But what you can do is create a module separately, put it in your private GitHub repository, and connect directly to this GitHub repository. Let me find some supporting documentation for that. So module sources. Here it is. There are variety of different things that allow you to distribute your module privately. First, what we did is local path, right? Just a folder next to your folder. But you can, for example, connect directly to GitHub, and if you have the access to this repository, and if it's private, and if you have all the credentials, it will pull, while others not able to pull. And different things. Bitbucket, regular Git repository, a lot of different options. But most often used are Git and local path, and also obviously public modules themselves. And also small correction. This module was created not by AWS. This module was created by open source enthusiasts, people similar to you guys, who have created some automation and decided to share it back with the community to help out other people. And also, what you can do if you would like to get like real experience, not just your pet project, right, where you put some simple application that only you contribute to, but if you want completely legit and valid open source experience, exposure to open source technologies, contributing to these public modules, I mean, not creating your module and uploading it to the repository, but contributing to something that already exists and something that's there already, and solving some issues, for example, in existing code bases and for popular modules, will give you a lot of credibility, will give you real experience, even if you are not currently like employed somewhere, right? And you can claim that it's like 100% valid and correct production experience. But uploading Hello World and pet project to GitHub is not open source contribution. Don't make no mistakes here. Okay, any other questions? Yes.
So my question is, what do you think about eBPF?
What do I
Extensions
think
of-
about eBPF? Very good and very interesting question. We have we've planned to investigate eBPF on my current project. We have not yet, I have not yet tried it, but it has some interesting use cases that will allow to simplify things, to improve things, especially in case of Kubernetes. Very good, very interesting question. Very good, and unfortunately, I'll be honest and straight. We will not cover eBPF as part of these classes, simply because I need to be confident in the technologies that I'm teaching. Right? You don't want an instructor who is trying to find out himself how to use a technology as he goes. Right?
Sorry, what is eBPF?
eBPF is a Linux kernel technology that allows to modify and customize network traffic and secure network traffic without having to create any sidecar proxies, any proxy technology, or and so on. It's like it's a very interesting thing. In order to understand, if I were to ask a person who is aware of these technologies, right? and if I were to answer this, I would say eBPF is better than service mesh. It allows us to achieve the same that service mesh has, but without having to set up service mesh, right? But then next question that you got is, what is service mesh, right? And to explain what is service mesh, in simple words, I could say it will improve your Kubernetes networking. It will give you more flexibility or more features on the networking level inside Kubernetes, and sometimes not inside Kubernetes. But majority of cases are Kubernetes. But then we need to talk about in details about Kubernetes, right? So this like Einstein was asked in simple words to explain the theory of relativity, and he said, "Now you explain me how to make an omelette, but explain me what is frying pan and what is egg." So that's what I will do is at this point I will just encourage you guys to keep learning, to keep moving forward in the right direction, to continue to be curious, and at sometimes it will start and at some point it will start make sense to you, and you'll be able to discuss eBPF and even implement it. And but we are not there yet, unfortunately. Yes, Ramdan.
So for you, how do you choose a cloud provider? What makes you choose AWS over Azure or
Mm-hmm. It depends from which angle we are looking at this. If you are, for example, IT director, you will assess cloud providers based on one set of criteria. If you are a startup owner, you will assess your cloud provider based on different set of criteria. If you are an individual contributor, you will assess which cloud to actually not even to choose, but to learn on the different set of parameters. So which hat do you want to try first? I believe individual contributor, right?
Yeah, from your point of view.
Yes.
As
So
a DevOps engineer.
As a DevOps engineer. So DevOps engineer, what's our goal as a DevOps engineer?
Make life easier for
So sorry, your voice is breaking. I cannot hear you.
make life easier for developers.
Make life easier for developer. Good. But why do we want to make life easier for developers? Why are we sitting here wasting our valuable time learning these
To have
technologies?
a product ready as
why do we want to
as
do
possible.
this? What's the purpose of our product?
To gain money.
How it will benefit us?
As
Yes, the goal is exactly the goal is to earn money by providing some value. And for you as a DevOps engineer, primary goal, if you are a regular engineer, to do your job well, so you get paid, right? And to get paid, you need to maximize your chances of having the most relevant and most demanded technologies, right? So then what you need to do? How do you assess which cloud is more popular across hiring managers, right? You should go to the job board, type the required position that you'd like, that you would like to apply to, and see what are requirements, and count how many times AWS is a requirement, how many times Google Cloud is a requirement, how many times Azure is a requirement, right? So this means, I did this exercise like a year ago, and the situation was that 60% of jobs had AWS as a requirement, like 20% of jobs had Google Cloud as a requirement, and also 20% Azure as a requirement. And I don't consider other like Asian clouds like Alibaba or minor players like Oracle Cloud or something like that. They're out of scope. I didn't count them. Now, what cloud, if 60% AWS, 20% Google Cloud, and 20% Azure, if we have this distribution, what cloud will make us a fit for the majority of job openings? Probably one that has 60% mentioned in the positions, right? And this is how you decide not only for which cloud, but which like next technology you want to learn. You want to be an expert in whatever is the most popular on the market. Then this will maximize your chances, maximize the number of opportunities that you have.
Okay, thank you.
Okay, and yeah, then it applied, and let's have a look what we have. Hopefully, it will work. It will work as expected. This is okay. Completely forgot. We already have HTTPS. Yes, it is working fine. Congratulations to all of us. And remaining, but not less important thing that we need to do is we need to clean after ourselves. Since we're using open source modules and nothing but open source modules, we can safely delete our modules folder. Let's run Terraform plan one more time, making sure everything is still working. It should show 0 changes, right? Same for level 1. Cool. Let's also make sure our formatting is right. And we can add and commit everything. And as usual, when we finish, don't forget to destroy everything if you don't want to be charged for the infrastructure that you forget to delete. And here we finish for today. If you don't have any questions, thank you very much, guys, and talk to you after next day and on Thursday as usual. And yeah, have a good rest of your day, or otherwise you can ask me questions.
Thank you.
Thank you for today.
Thank you. Bye.
Bye.
Thank you. Bye.